WebSockets are an incredible way to build high performance real time communication with other systems. What I'm going to show in this following demo is how, from scratch, to use Rust to build a high performance interface for SQLite. This is really a strategy for building things like real time database interactions, updating data science workflows, doing things with machine learning, maybe building games. Let's talk about the architecture first here. We have a web client. In this case, it'll be a query editor. We also have real-time chart visualizations, and we also have the ability to do real-time displays. Now, in terms of the Rust server itself, we have a WebSocket handler, and this WebSocket handler opens up a socket and does TCP connections back to the client. So the browser itself is getting real-time information. You can think of it a little bit like a pipe that has water inside of it. You turn on the pipe and it just starts flowing, and the pipe could even be bidirectional as well. And if we look at the query here, the query is going to talk to an in-memory version of SQLite. It could also talk to a on-disk version of SQLite. And then we have the SQLite database itself. So this is all available with Rust, which is an extremely high performance and efficient way to do things. So next up, let's go ahead and take a look at the code. All right, here we have a project that is a SQLite WebSocket demo. Let's first look at the overall architecture by looking at this README file and getting a feel for what it is it's going to do. So first we have SQLite WebSocket microservice. We have an in-memory SQLite database that talks to a music catalog schema. The WebSocket itself does the query protocol. We also have asynchronous query execution and then real-time result streaming. The core components here are static files. We also have, the ability to talk to this database, etc. So that's the overview. Now let's go ahead and look at the code and look at the structure on disk. First, let me show you what I do sometimes to look at the structure of a Rust project because it has artifacts and target. Is I'll type in tree space dash uppercase I and then space target in quotes. And what will happen here is we see SQLite WebSocket demo. We have a cargo.toml file. We have migrations. We have the source code. So a db.rs, error.rs, main.rs, models.rs, websocket.rs, and static index.html. So this is the structure of the project. And let's go ahead and walk through each of these files one by one. So first up, let's take a look at the database. That'd probably be a good place to start. And if we look at this database file here, this is where we interact with SQLite. We use these crates here. So we say crate models. We have base 64. And we also use libraries like R2D2, which allows us to talk to SQLite. And at the very beginning here, what we do is we initialize this database because this is a little bit different. It's a demo project. I initialize the database in memory so that we can just play around with it and really get the feel for how SQLite works. You can see that the SQL statement says create the table if it doesn't exist. And then we insert this inside. We put these songs, right? Stairway to Heaven, Back in Black, Master of Puppets, etc. And then if we scroll down here, we can see that we have the pub struct DB connection, and we have a new connection created. So this is the initial connection to SQLite, and also we execute that init SQL, right? So we execute this code to populate the database. Then we have execute query, and this is where we do these queries. Notice that it accepts a query string right here. So this is where we could populate the queries inside. And then finally, we go and we return back that result. Next up here, let's take a look at the model. And if we look at the model here, this is just structs. So we have error response, query response, messages, query result. We also have value as well. And then in terms of the errors here, this is where we would handle errors like database connection errors. And the only thing left to talk about is the WebSocket code and then the main code. So let's go ahead and take a look at the WebSocket here next. So in terms of the WebSocket, again, the idea with a WebSocket is it's a bidirectional pipe. Think of it as like a water pipe that things can go in and they can come back. So it's maybe a bidirectional water pipe. Same thing, but with data. We use Actix. We have a stream handler, which allows us to communicate with the WebSocket. And then we make this WebSocket connection here that is protected by a mutex. And then if we go down here, what happens next is we're able to use this connection here, the WebSocket, and say, hey, let's go ahead and say that we've successfully talked to the WebSocket server. Now you could put some other kind of acknowledgement as well. Like you could say, the game server has started or database communication has started, but this is just for demo. I made it really simple, but you could put anything you want here that appears inside. Now, in terms of the handler here, this is where you would go through and handle the different errors. So you have, what happens if I have an error? What do I do? Etc. Like for example, in this case, we return back a invalid message. And then at the very end here, we also have the stop and close, right? When we want to disconnect from that WebSocket. So the last thing to cover would be the main here. And if we look at the main, this is really small because all of the other files do the heavy lifting. So we have the imports here at the very beginning, the Actix web server. We also use our modules, right? So we say mod DB, mod errors, mod models, mod WS for the WebSocket. And then at this point, we build a very basic website that talks to a static page, index.html, which we'll get to in a second. And then we make an instance of this, an async connection. And then at the very end, we just go through and we expose it. So this could easily be containerized as well. And we could put it into a very high performance container. So the only thing really left to show would be to go to our static page here and look at the index.html. So what happens here is that we use a chart library. In this case, this is a real-time SQL collaboration demo, and we have this JavaScript that's available from this chart.min.js. And then we have some styling to make it a little bit fancier, right? This is the CSS. And then if we scroll down here, now we have the real meat of our demo, which is we have a real-time SQL collaboration demo. And then inside of here, we have on-click events, right? So this is going to send the query, in this case, to our SQLite database through the WebSocket. And then we have some JavaScript that goes through here and does the operation. So we have, in this case, a basic operation, an aggregate operation, right? And then we also chart out that information via JavaScript. Here's our connection logic right here. So we say function connect WebSocket, get element by ID. And then in this case, this is the on message. Right here, we just say for each. We go through and we display what's coming back. We also have some JavaScript that is a update of the chart. And then we also have a send query as well. And then at the very end here, we have window on load, which makes everything work. So not terrible as well to get this WebSocket working inside of index.html. So let's go ahead and go into the right directory here and let's type in cargo run. And then it runs into the foreground mode. All right, so now we're in this environment where we have a real-time SQL collaboration, a demo site, and you can see here that I'm connected to the WebSocket. If I refresh it, you can see it disconnects for a second, and then it reestablishes that WebSocket connection. So again, think of this as a pipe that's shoved inside of here, and I can do this real-time communication. Now, in this case, right here, we have select star from track. So let's go ahead and get 5 results. There we go. Very fast results here. We get those queries from the database. Now, what we want to do as well is probably make this a little bit bigger and let this thing show everything that we want to build. And we can do that by going like this. And if we go and we look at aggregation here as well, if we click that button in real time, it lets us get that aggregation cooking as well. And what's nice about that is that it lets us see, for example, data visualization results. So we can look at the count, right? So how many Guns N' Roses songs or how many Metallica songs. And again, this is very fast because it's real time. And then if we want to look at chart data, as well. We can see a different query, select artist, average duration as average duration from tracks, group by artist, order by average duration. Bam. And we go through here and we see these query results. So what's really cool about WebSockets is it allows you to build these very interesting tools. Like, for example, real-time data visualization would work very well with Rust and WebSockets. And that's really the takeaway here, is that there are many use cases of Rust in terms of real-world data science